All right, welcome to 11E, and welcome to my third period class. They're really excited to be a part of the notes today. Hopefully they don't ruin it. We're going to look at volume of three-dimensional shapes. Some quick reminders as to what volume is. Volume is the measure of the amount of space that a figure encloses, and it's measured in cubic units. Okay, cubic units. The capital letter B, and this is spelled out on your formula sheet, but the capital letter B is often found in volume formulas. The capital letter B represents the area of the base. Okay. Do not forget that the bases are the two parallel sides and parallel and congruent sides or faces of the prism. Okay. And then don't forget that the height is a perpendicular segment, both the height of the base or the height of the prism or the height of the cylinder or whatever. It's always got to be perpendicular to where it lands to the base. Okay? Give you a second to copy that. If you need more time, you feel free to pause the video. I literally gave you a second. The volume of prisms. So if a prism has a volume of V cubic units, and I'm reading this key concept part right here, okay? Then the volume formula is capital B times H, okay? So the capital B, we know that's the area of the base, okay? So the area of a triangle for a triangular prism. And then the area of a triangle, we know that formula is 1/2 base times height. So for this triangle over here that we're looking at, there's something we have to do first. We want to do what you see 1/2 times 8 times 15 right here, and you might be wondering where the 15 came from. A lot of times when we have these problems, there's information that we're going to have to find first. So if you look over here on the right side, we're going to use Pythagorean theorem in this case. I know that it's a right triangle, so I'm able to use Pythagorean theorem. And I can do 8 squared plus a squared equals 17 squared. I get 64 plus a squared equals 289. A squared equals 225. And a is 15. Okay? So there are oftentimes, the harder part about this unit is that the formulas are the same as they've always been when you've used them, but we're going to have to use things, facts, whatever, that we now know in order to find new information to be able to complete the problem. So once we have that as 15, then we just plug that into the area of the triangle. So 1/2 times 8 times 15 is 60. From there, the volume is the area of the base, which is that 60 times the height. And h is the distance between the bases. We have to remember that the height is always the distance between the bases. Okay? So we have 60, and then the distance between the bases here is 13. So 60 times 13 for an answer of 793 centimeters cubed. And that's how we do volume of a triangular prism. Pretty easy as long as we remember to find the parts that we're missing. The volume formula for a cylinder is it's the same as a triangular prism. The difference is that now instead of using 1/2 times base times height for the area of the triangle, which was the base, now we use the formula for a circle. So pi r squared times the height. So if we look at this first one here on example A, we have 12.4 times 4.6 squared times pi. We have to, and we're just multiplying those. We get the pi r squared is the formula, so it's literally just pi right here times r squared times the height. A lot of times on the SOL or on tests or quizzes, you may be allowed to leave it in terms of pi there for 262 pi, or you may be asked to round. For example, this one is rounded to the nearest tenth. Okay. If we take a look at part B, same idea. The mistake here is, what do you guys think the most common mistake is here on part B? Using 13 for the height, that's one common mistake. Another one is using 5 for the radius. Okay, 5 here, this 5 right here is the diameter. All right, so when we do pi r squared h, we have to make sure that we change the r. We're not changing it. R is 2.5. Okay, from there, it's just simple calculation. Okay, 2.5 squared times 12 times pi. All right, now, what if we weren't given 5? What if we were asked to do this problem and you couldn't see that? Do you have a way, could we figure out what the radius of that circle or of that cylinder is? Anybody guess? Yeah, we can watch it. We could use the Pythagorean theorem this right here, because it's the height, we know that that's a right angle. So we could use the Pythagorean theorem to find the diameter that would then allow us to cut that in half and find the radius. So that's an example of a problem you could see. Volume of pyramids. Okay, so very similar to, again, still using base and height, but it's obviously not the same amount of volume inside as a prism. So we're taking 1/3 of base times height. You have to make sure that you know what the base of the pyramid is. Some pyramids have a base that's a triangle. Some pyramids will have a base that's a square or a rectangle, and then others will have other polygons also. And usually in those problems, you'll be given some sort of clue or hint as to what the area of the base is. For this problem, it says Travis is making a plaster model of the food guide pyramid. It's a square pyramid. I got to make sure I read the problem and I see that that's a square pyramid. So I'm going to take capital B is the area of the base. In this case, that's a square. So the area of the base is 144. It's just 12 squared. And then the height is 15. So this is 1/3 times 144 times 15 for 720. These problems, as long as you can find the information that you're looking for, the missing part, or find the area of the base, these problems are usually pretty straightforward. Take a look at cones. The cone formula is very similar. It's 1/3 times the area of the base times the height. The area of the base now is a circle. There's lots of opportunities in cone problems for us to use Pythagorean theorem to find perhaps the height. If we were given the slant length here, for example, we might have to find the height. You have to be prepared for that. So there's different things that we'll have to do as far as finding answers. But there's not a lot to these problems if you just plug in what you know. This is 1/3 times pi times 8 squared times 8. And again, sometimes you leave the answer in terms of pi, so 51/3 pi, or 536.2 inches cubed. If you look at B is a little bit more difficult because on B, we don't have the radius. Okay, we don't have the radius. So how can we find the radius? Well, you have to look at what we are given. We have all these tools with right triangles. We have Pythagorean theorem. We have special right triangles. That doesn't work for this problem. We have another method of finding the radius here. Anybody remember? Somebody in the back who's a very good American Sign Language student just signed trig. That student is correct. We're going to use trigonometry. We have an angle right here. We have the height, and we need this missing side. So if we go back to our trig days when we memorized this, SOHCAHTOA, I have the opposite. I'm looking for the adjacent, so I'm going to use tan as a color, and we're going to use tangent. Okay, so the tangent of 48 equals 10 over x. You do that and you end up with x being 9. Okay, about 9. Now that we have that for the radius, we can go ahead and just plug that right into the formula. It's pretty simple from there, just doing the calculations. You just have to make sure that you're finding the missing pieces using the facts that we've learned, things that we've already learned this year in different units, especially the right triangle stuff comes up over and over and over and over and over. Okay? Volume of spheres. So sphere was the one shape that we did last time. It didn't have a lateral area. It did have a surface area. The volume formula for a sphere is 4/3 pi r cubed. And again, all of the volume formulas are on your formula sheet, so just get used to looking for them on there, find them, and be able to apply them. But 4/3 pi r cubed, it's really that easy. Sometimes we get some big numbers. For example, on A here, the radius is 24. So that's going to be 24 cubed, which is a huge number. And then 4/3 of that huge number is 18,432 pi. Okay. I like this second problem because they give us a sphere with a circumference of 36. How would we find the radius? Okay, because we can't do part B without having the radius. And the answer to that is you're gonna if we know that circumference is 2 pi r, then we can take 36, plug it in for C, and solve. So if we take 36, we plug that in for C, then I end up dividing both sides by 2 pi. I divide both sides by 2 pi to solve for r, and r is 5.73. Now, once I have that, it's easy again. It's 4/3 times pi times 5.73 cubed. Okay? But that's, again, another example of a problem where you have to find something that's missing in order to be able to answer the question. Okay? Once we get there, it's just calculation stuff to get to the answer. Heard a great joke this morning while you guys were taking a look at that from one of my students. I would repeat it, but I think it would offend some of you. What was the joke again? For those that couldn't hear, what do you call a cow with a twitch? You're never going to guess. So the answer is beef jerky. God. No one. That wasn't a laugh. That was a girl crying. So this is sad now. Beef jerky, it's a real zinger. Let's take a look at these special cases. Sometimes we have obliques. We have an oblique cylinder here. This is a cylinder that doesn't fall into our normal, soup can kind of analogy of what a cylinder looks like. But the formula is still the same. It's pi r squared h. Here we just have to know that the height of the oblique cylinder has to land at a right angle. It has to be perpendicular to the base. But the formula is the same. There's nothing different about the formula. Okay? Same here with an oblique cone. Does it look different? Yes, but it's got a height of 12 and it's got a radius of 8.6, so the calculation is the same, and it's the same formula. It just looks different. Don't be tricked by it looking different. See if you can find the information that you need and then plug it into the formula and solve the problem. Okay. The last page is a really good example of a word problem that you could get like on a test or the SOL or something like that, because it makes you apply volume formulas to a problem. So the water level in a rectangular prism tank, 30 centimeters by 20 by 10, and it tells you 10 high. And it says a rock is submerged in the tank and it raises the water level 0.5 centimeters. And then the question is, what's the volume of the rock? Okay? What's the volume of the rock? So what can we do? There's no formula for volume of a weird shaped thingy. But we do have formulas that can calculate the area of this water here. We could calculate the area of that. Okay? Then we could calculate we could calculate the volume of that. Then we could calculate the volume of the water after the rock's been placed in it. The difference between the two, the only difference between this and this is the rock. So if we calculate the volume here and then the volume here and subtract them, we'll have the volume of the rock. I'm going to pause it and let my third period geniuses work this problem. All right, so my students are working the problem. What they're doing is they're looking for the volume of the rectangle of the water on the right by taking the area of the base, which is 30 by 20, and then multiplying that by 10 to get that volume. They're also calculating the volume over here on the right by again doing 30 by 20 for the area of the base, and then the height is now 10.5. So can somebody help me out? What's the volume for the water on the left? 6,000 centimeters cubed. That's for Miss Ottinger. And on the right, what's the volume? 6,300 centimeters cubed. So we know that the volume of the rock is what? It's 300 centimeters cubed, because it's the difference between the two. And that's it. Those are the notes. That was quick and painless. Great job on my third block, except for this one student who waves a lot. He's okay though. All right. See you guys. Quiz next time, right? Yep. See ya.
That's all, folks.